Let's take a look at topic 5.5, example 5, and we are going to write a rule for a composite function. So what is the rule for? And now we see some unusual notation. This is new notation. That is not an O in the middle. That is just a tiny circle, and that is a symbol that we use for a composition of functions. This is read as f of g of x. So here we go. We are going to find the rule for f of g of x. F of g of x is the same as saying f of g of x. They're both spoken the exact same way, but they have a different representation, and you could see them either way. So that means now I have f, and I'm going to input whatever my g of x is. So my g of x is 2x minus 5. And now my function f of x is the square root of x plus 7. So what I'm going to do is I'm going to put in my radical, and I'm going to put in some parentheses. And oops, I had the plus 7. Let me add that in. So I have x plus 7. And my x, what I'm substituting in for that variable, is now 2x minus 5, another function. And now let's simplify. (2x minus 5 plus 7), this is 2x plus 2. Square root of 2x plus 2. Let's take a look at b. Now we have f of x equals x squared plus x plus 2, and g of x equals 4 minus x. So let's again find f of g of x. And again, I'm going to write it out all the way. This is the same as f of g of x. G of x is your input. Which is the same as saying f. And then inputting g of x in, which is 4 minus x. And now let's grab our function f. Wherever I have an x, I'm just going to leave a space. I'm going to use parentheses. So I have x squared plus x plus 2. And inside my parentheses is going to go that 4 minus x. Okay, and now let's simplify. 4 minus x squared, that is a perfect square trinomial. I'm just going to apply my polynomial identity. If you're not comfortable using those identities, again, feel free, just write it out. Quantity 4 minus x times the quantity 4 minus x. You can use your distributive property, FOIL it. You're going to arrive at the exact same answer. So here I'm going to have 16 minus 8x plus x squared plus 4 minus x plus 2. And now let's just clean this up. I'm going to go ahead and start working this, putting this in standard form. So I have x squared If I look for my x terms, I have a negative 8x and a negative x, so that's a negative 9x. And then I have a 16 of 4, so that's 20, and then plus 2, so that's 22. So f of g of x equals x squared minus 9x plus 22. Let's take a look at your try-its again. If you missed class, feel free, pause the video, give them a try on your own, and then come on back and check your answers. So here we go. We're going to find f of g of x and g of f of x. So let's take a look at what that looks like. F of g of x, we just did several like this, is the same, again, as f, where g of x is your input, so I have f, and my input is x plus 1. So now I'm going to get my function f is x cubed. So again, I'm just going to do my parentheses, put my exponent of 3 in, and then within my parentheses, I'm going to drop in the x plus 1. And now let's simplify. This guy, let's expand him out a little bit. This is x plus 1 times x plus 1 times x plus 1. X plus 1 raised to the third power. You're multiplying that binomial by itself 3 times. I'm going to leave my first binomial alone. Let's multiply these two. And again, this is another polynomial ID. This is, again, is a perfect square trinomial. This is going to break down to x squared plus 2x plus 1. And now let's distribute the x plus 1. X times x squared is x to the third. X times 2x is 2x squared. X times 1 is x. And now let's distribute the 1. Well, if we multiply by 1, we're not changing any values, so this is going to stay the same. X squared plus 2x plus 1. And now let's combine like terms. Let's put this in descending degree order, standard form. Highest exponent is 3, so we have x to the third. Here is a 2x squared and an x squared, so that's 3x squared. My x terms, I have an x plus 2x, so that's 3x. And I only have 1 as my constant, so this is plus 1. So f of g of x is x cubed plus 3x squared plus 3x plus 1. Now let's take a look at g of f of x. So now we're going to grab our function g first. Let's write it out, g. And f of x is going to become our input. So g, let's put f of x in there. My input now is f of x, so I'm going to put in x cubed. So g of x is x plus 1. So again, I'm just going to leave a space wherever I have an x. And I'm going to input f of x in there, which is x to the third power. And when you simplify that, you get x to the third plus 1. So notice f of g of x gets us an answer of x cubed plus 3x squared plus 3x plus 1. Now if I compose it the other direction and I go g of f of x, excuse me, I get x cubed plus 1. Let's do another. Let's go f of g of x. So again, function f, and my g of x, we got g of x, that's my input. So now I have f. My g of x is x minus 5. So now let's grab function f. Function f is x squared plus 1. So again, wherever I see that variable, I'm just going to leave a space. So it's x squared plus 1. And now let's put in the x minus 5. And now let's simplify. Again, we have a perfect square trinomial, so this is x squared minus 10x plus 25 plus 1. Well, you only have to combine like terms in your constants. X squared minus 10x plus 26. Here's our answer. So that is f of g of x. Let's take a look at g of f of x. So we will have now g of f of x. So I'm taking function g first. G. And my input is going to be f of x. So again, I'm going to write this out. G f of x is x squared plus 1. And so now let's grab our function g. It's x minus 5. So again, wherever I have a variable, I'm just going to leave a space. And my input now is x squared plus 1. And so now when I simplify, I get x squared. 1 minus 5 is a negative 4. X squared minus 4.